Ever wondered what the domain of a function is in mathematics? It's a fundamental concept that helps us understand how functions work. Essentially, the domain of a function is a collection of all possible inputs or independent variables that the function can accept without causing any undefined operations. It's like a function's playground where it happily exists and operates. In mathematical notation, you might see it represented as df or domf, where f is our function. So simply put, the domain of a function is where the function exists and is defined. Now, how do we determine the domain of a function? Well, the process involves identifying any restrictions or limitations imposed by the function's definition. These restrictions could be due to fractions, square roots, logarithms, or inverse trigonometric functions. Let's start with fractions. The denominator in a fraction cannot be 0, so if you have a function with a fraction, the values that make the denominator 0 are not included in the domain. Next, we have square roots. The argument of a square root, meaning the value under the root sign, must be non-negative. It has to be greater than or equal to 0. If it's less than 0, we'd have an imaginary number, and that's not included in the domain. Then come logarithms. The argument of a logarithm must be positive. It needs to be greater than 0 and not equal to 1. So, in a function involving a logarithm, the domain includes all values greater than 0, but not 1. Lastly, inverse trigonometric functions. The argument of these functions must lie within the range of its corresponding trigonometric function. For instance, the inverse sine function only takes arguments between -1 and 1. By considering these restrictions, we can determine the domain of any given function. And remember, the domain is essential as it tells us the range of valid inputs that produce meaningful outputs. Understanding the domain is a crucial step in analyzing any mathematical function. Let's delve into some examples to better understand how to find the domain of a function. Consider function f(x) equals x plus 3. The domain here is all real numbers, as there are no restrictions. Now, if we look at gx equals 3 divided by x, the domain excludes 0, because the denominator cannot be 0. And in the case of hx equals the square root of x, the domain is all non-negative numbers, since a square root can't be negative. And there you have it, some examples of how to determine the domain of a function. Now that you know what a domain is and how to determine it, it's time to wrap up. We've covered the definition of a domain, the methods to ascertain it, and looked at examples of how to find domains in various types of functions. Grasping the concept of a domain in mathematics is critical. It's the range of valid inputs that yield meaningful outputs. Remember, the domain of a function is a fundamental part of its definition, and knowing how to determine it is key to understanding and analyzing mathematical functions. Thanks for joining us today.